Okay, thank you very much. Hi, everybody, and good evening. Thank you, Matt, for inviting me to this presentation. I think we have heard from GIS surveying, and we have heard from architecture, and now it's my part to say some words from the engineering. The title is 3D Planning and Simulation of Crucial Infrastructure, and it says failure is not an option. I mean, failure is an option, but if you spend many millions of euro to plan projects or to build projects, failure is very expensive. So that is what we work on and try to have tools, or we develop tools not to fail. My topics for the next, let's say maybe 30 or 40 minutes, I would say some words to my company. Then I would like to show something of the making of, like behind the scenes of 3D models in engineering. And then I have 3 examples from projects, one in civil engineering, one is a digital twin in Switzerland, and the third one is plan and build from a port in Basel, Switzerland. Public relations will show you how you can talk to people without talking to people. And last but not least, I would like to show some small technologies that are, let's say, low cost or cheaper kinds of simulations. I am 51 years old. I have 2 daughters. One is 20 years old, and the small daughter is going to be 18 in December this year. So I am working in simulations, visualizations since almost 30 years. When Falcon Media was founded in the year 1993, I started studying at the university in Trier, and Falcon Media was out of a research at the university in Trier. So in my very first year, I heard a presentation from the founder of Falcon Media, and I asked him if they would need some more people, some more crazy people, and that was my time to come into Falcon Media. We are based in Trier in Germany, and we have the 2 engineers, that is the founder and me. We have 10 employees that are 3D artists, computer scientists, and graphic designers. And since nowadays, we well have more than 500 projects. And I think right now it's 548. And mostly it's kind of big projects of civil engineering. Let's see, the making of computer models in civil engineering is based on surveying. What is the next pictures showing how the models are built. If I say models, I'm talking of the scene, how it looks like today. So the surveying, the surface is finished with satellite pictures. If my English is not too good, I have to be honest, it's my first English presentation in 4 or 5 years. So I do my very best. So we put the satellite pictures on the surface, or even we go out with a drone and take the pictures. And as we put on the houses, you can see the 3D starts to be alive. In the houses, we are talking about 3 different level of details. Level of detail 2 is what you see here. So you have no doors, you have no windows, but you can see the shape of the roofs. Level of detail 1 would be that you only have simple cubes. Level of detail 3 would be realistic with textures of the houses. That is going to be my next example. Very important is plants, trees, and hedges. we put in the models, because the whole virtual reality models we built over more than, I would say, maybe 10, 15, sometimes even 30 or 40 kilometers, you need the houses and the plants to have a realistic surrounding area. When we start importing the engineering data, we first have the asphalt, which comes either out of 2D plannings, what is still useful, I would say, in maybe 50% of the projects. Some projects are built in 3D, like building information modeling. Then it is easier for us. Maybe in this yellow circle, you can see that we have a tunnel. Tunnels and bridges are mostly built in building information modeling. So we can import these as 3D models and put all this together. And the next picture shows that we have a marking on the street, which makes the street look like a street. What is very important. And the next picture shows that we have the pillars and the buildings of the bridge. And the last picture shows you how it looks like when even the plants that are planned on the new surfaces are in the model. So we have the scene, how it's going to look like in the future. After building this 3D model, I would like to live demonstrate how it looks like in our self-developed software Vismo. Might take a couple of seconds to start, because we are importing now about 1.5 up to 3.5 gigabyte of data. And I will show you the position we have just seen from the making of. I think it's kind of late for my computer also. Let's give him a couple seconds. That is what could happen in a live demonstration. I'll give it a couple of more seconds, or I need another try. There we go. So now we are at the point we have just left the PowerPoint presentation. And as you can see, the cars are driving, and I can use my mouse and my keyboard to navigate in the real-time model. When we started out about 30 years ago, we made pictures with normal cameras, not digital cameras. It's 30 years ago. And we took pictures and we made visualizations in like 1 or 2 or 3, 4 pictures from bridges and from streets. And no matter how many pictures we made, there is always a wish to have one more perspective. And that was the reason we started out making real-time models. Vismo is developed since almost 20 years and has many functional tools, like you can even turn the light out. This is not an architecture light, this is a realistic light, because it's meant to look how shadows are walking over the day. So that is one thing. I can go closer so you can see how much detail is in these models. And the very important thing is you can switch in between today and future, and that on any point in the scene. Because many people are asking, how will the bridge look like if I maybe live here, or if I go down here, if I walk on this way, I can also drop myself down. Now I am just walking around, and I can have a look and see how it is without or with a bridge. The problem is always the same. If you build streets and bridges, nobody wants to have them in front of their houses or nearby the house, but everybody will use bridges and streets when they are built. So one question is, how does the scene look like before and after? But a more important, or let's say in the last 5 or 7 years, more important was how will the building site be looking like? So we are not just able to have the scene before and after in real time. We can also have the different steps of the building site. And I can just switch these steps here like variations. And even animations in real time is visualized in Vismo. So Vismo is made to make a presentation for maybe, let's say 300, 500, up to 2,500 people that you invite. And that is the people that live around in an area where a street like this is being built. This is a project in the middle of Germany. And is being presented in the, I think from January until February, they will start talking to the people, because this is planned right now and has to be communicated to all the people. If I go back here, you can see is a tunnel. So no matter where you are in the model, if you switch back to the situation today and start for the different steps in the building site, it is possible at any point in the presentation. That is the difference between engineers and architects. The architects need 2 or 3 very nice pictures to sell, but the engineers need to demonstrate what they are doing, and the building site is getting more and more important since a couple of years, because the building sites are being there for, I would say, over 3, 5, or 7 years. So the people want to know what is happening in that time. And people are interested in how the bridges are going to be built until the final situation. A question that is always asked if you are standing in front of 500 people is maybe, how far is my house away from the street? And you can do measurements. Let's see, I can display the measurements on the up left side, because when you are in a sports hall with a couple of hundred people and people are asking, they should see what you are doing, and you can either distances, or you can also see how big is a field, like this here, and it shows you the square meters. So what we build is one-to-one models, like building information modeling. It is not a scaled model. It's a model that is exactly the same as it's going to be built. So that is maybe one example for civil engineering. And I would like to show you another example in Switzerland, which shows you a digital twin. Digital twin is in infrastructure projects coming up since, I would say, maybe 5 or 7 years. That means digital twins are the basic 3D models for plannings that are happening. And this is in the middle of Basel. It's the Freie Straße. I don't know if a free street would be a right translation. And the people have been asking, why do you spend millions of euro or Schweizer Franken to build just a new surface? Because this is how it looks today. And this is how it's going to look like when they are finished. And this looks kind of easy, but it gets more and more difficult if you look in the underground. Like I can select the gas pipes, canal, power, and water. And now it is easier to explain to people what is happening, because all these or many of these pipes have to be renewed. That means you cannot just change the surface. There's much more happening underground. And that was the reason we built this digital twin in the upper level, what should look nice, and in the underground, that shows why it's a critical project to build and why it's very expensive. The functions are about the same. You have measurements, you have you can also change the lights. Like if you do renderings, we have a camera here, or this button is for videos. So in our software, you can choose your perspective, choose what you want to see, and then you can render a picture or a video, which can be used for a presentation or just for email. And if I go up, you can see that we have a surrounding area of a couple of kilometers, square kilometers, but this is the interesting part for this project. So we always try to have a surrounding area because you have the horizon you need if you make renderings. Let's see the third project that is also in Switzerland. This was a project we have visualized about 1 year ago. We have worked together with the planners, because in the port of Basel, you have railways, waterways, and you have streets, bridges that are being built, and also industrial buildings that will change. So our goal was to develop this model, including moving traffic, and to be able to change variations on any point of view. And as you can see here, if I wait a couple of seconds, even a loading process from the ships is being simulated in this model. And also there should be a train coming soon. Let's see, we have I know that there is a ship going in. And as you can see, it is a very close situation. So what I mean with that is the idea of building information modeling, that you build 3D models to try if something works. If it does not work, you're able to react before you start deeper plannings, detailed plannings, or if you start even the building site. So it is very important for projects like this to be sure that everything is working. So this ship will go through. I think the captain cabin must come down. Let's wait a couple seconds and you will see that even the captain cabin will go down. Okay, it looks like it works. It is closed, but it does work. So together with the planners, it took us like, I would say maybe 3.5 to 4 months to build this complete model. And I had, I would say, 3 people working for these 3 months. And as you can see, there's many more details no matter where you go into the model. These pictures are made from drones. That is what I said, level of detail 3. This is what we would call level of detail 3 because the houses have real textures. So it looks like almost realistic. Not as nice as your pictures, Marcus, because you know the problems. And I think it was funny to listen to you because we are all struggling with the same problems over years. And we had to decide if we have more technology in real time or if we have the best quality. The best quality is what you have if you render one single picture. But flexibility and more technologies, that is what you have if you are in a real-time model. So maybe that is enough for you seeing projects in real time. That is what we do, what we develop for engineers or maybe architects for these big projects. If they need to be shown to public, or maybe if they need to be shown over a video conference for the planners. So one thing is to see how it is before and after and how does it look like in real time on the building site. The second thing is we develop Vismo Dialog. Vismo Dialog is meant as a standalone website, or it can be also be a part of your website. It is an online information system where you can leave comments, or you can make a detailed and have a detailed information. So it is meant for spreading for a widely spreading from information for any people that are interested in your planning. And it is meant even before you start to plan, you can listen into people, because you can, in a 2D simple way, you can say what you are planning and people can make comments and you can see what people are interested in. So what is important if you're planning before you start planning detailed. And we also have 360 panoramic views, and I will show you this also live. So this is how it looks like in a browser. You can zoom in, zoom out. It looks like mostly like Google Earth maybe. I can switch in different variations. This is the situation without bridge, and the planning is with the new planning shown. Or if you do not have a complete computer model, if you only have an idea of a planning, we can also just put the planning into an easy card in the background. Information to projects on the upper left, or Schedule is one thing. Important thing is documents, because we are engineers. We want to make plannings want to make people being able to download plans or to have a look at the plans. So our customers have a back-end system. They can log in and they can show any kind of documents, PDFs online, which is meant for either simple plans or expertises or any other information in PDF. The main thing for the big projects, for infrastructure projects, is to be transparent. So we want our customers to have tools to be able to inform not only 500, 2,000 people. In some cases, we have interests about maybe, I would say, 10 up to 15,000 people. And these people can walk around in this system and also are able to view in 360 panoramics. And this is almost like being able to walk around free, like in a real-time model or in a walkthrough. The quality is very high, so you can zoom in and have a look at details. And even if you zoom in and switch, the situation is, the perspective is going to be the same. That is very important if you want to see before and after. The traffic stands still because this is a rendering, it's not moving, but I think it is a lot easier for people to be able to just inform themselves with a mouse click, not have to use a head-mounted display or have to use an Xbox controller, because this is meant for everybody at home. The data that is transported, I mean, I would say more than 80% of the people have a very good internet connection at home, but even with a bad connection, it's possible to reach out. Let's see. My own window blocked here with the, there we go. Because we are engineers, we wanted to make the very important measurements also. The people can click here and there and see the house is like 146 meters away, or you can see how big is the court. So you can do either distances or shape measurements. On the bottom left, we have different kinds of information, but that will be too much to show today. So the important thing is that this system will be running in the internet and is very high performant. So you do not need a very big computer. I would now like to show you some more easy and some more cheaper ways of visualization. One is the 360 video and panoramic you have already seen. The 360 video, I can show you one right here. That is a good option to upload a video to YouTube, and also meant for many thousands or hundreds of people to inform themselves at home. You can stop the video and you turn around with the mouse. If you start it on a tablet, on a mobile device, you can just turn the mobile device and look around. But I guess the people in this audience all know about this technology. Another option to presentate projects is film and animation. I will not show you films and animations right now because I think we all know about what image film is like. Image films we made about 20 years ago, or building construction films, they took about 8 to 12 or 14 minutes. What we see today is that nobody wants to take time longer than maybe 2 or 3 minutes to be informed. So before I would make a video that is like 8 minutes long, I would rather say use Vismo, walkthrough, and make your own small videos from the building site in that points that is helpful for you. But still, I want to show you that the government still wants complete videos that are with music and speaker professional. Like Marcus said before, the 2D pictures are still nice to see. And this is what we started out with many years ago, but it's still nice if you do not want to build a complete surrounding area. So taking a picture from today, as you can see on the left, and then put in the computer rendering into this picture is still very nice to see if you only need 1 or 2 pictures. The only thing that is that you are struggling with is the work you have in Photoshop. Because the situation before and after always means that some people park their cars somewhere that you have to take out, or you have to make the changes that you're planning is responsible for. 2 more things I want to show you is Vismo VR. It's my same opinion as Marcus said. We have developed this about 7 years ago, and when Corona came, nobody wanted to try a head-mounted display. That is the one reason. The second reason is that nobody wants to destroy his haircut. That sounds like many minus for the head-mounted display. There's a big plus. If you're only with a couple of people, maybe 2 or 4 people, it is very nice to wear a head-mounted display, and the imagination is very powerful. So if you want to inform many people, I would say is more than 10 or even more than 100 or 200. The head-mounted display is not a good option because you would need 5 to 10 minutes per person, and that would take very long. So the head-mounted display for us is mostly an option if you have only some people that want to show maybe a building site in real time. Last but not least, we developed a Vismo terminal that is meant like a big tablet. It's 32 sol, I don't know, even inches, 32 inches. It can be carried with 2 people, can be put in any car, and just needs power, no internet. So you can set it up anywhere where you want to inform people about your projects. So that is meant if you have a conference room and put up a Vismo terminal like this, it could stand there for a couple of weeks or a couple of months and could be updated if necessary. From the software, anything is possible. We can run a real-time model on the Vismo terminal, or we can just have 2D plans or 2D pictures. Even a PowerPoint presentation can be started on the terminal. I think because it's very, very late, I say thank you very much for listening. And that is what I wanted to show you about the engineering world. I hope you enjoyed.
All right, I'm coming back in here. Thank you, Oliver, so much for the presentation. This stuff is very, very impressive. I mean, just the model, seeing everything in real time, and also knowing that you are developing all the 3D tools yourselves is incredible. It's absolutely incredible. Yeah, so we do have a little bit of time for questions, and so far I didn't see anything yet from the audience, but there are certainly things that we can talk about. I got a couple of notes, as always, and like going back to the original title of the presentation where you said failure is not an option, and we see it here again. Can you give us just a hint of examples of things that during your many projects where you actually uncovered certain things that people said, okay, wow, we're super glad that we kind of took the time to go into planning these things thoroughly in 3D, and so if we didn't do this, we would have like, and you mentioned at the beginning, millions of damages to pay. Can you give us a few anecdotes?
One of the most important anecdote was, I think it was about 15 years ago when we started out with the walkthrough models. We had a planning of a what's the name of a highway. I think it was even 2 highways that were crossing, and the height between the highways is definitely about I would say maybe 6 meters 20. And the planners, they were working with 4 different companies. They had a 6 meters 20, but they forgot the bridge. So the bridge was 1 meter 60. And what was left was not enough for a truck to drive under. And that is what we have seen in our 3D scene. So for us, it looked like a very small failure. But if you make all the plannings, if you make all the detailed plannings with 4 companies, and you go into the process of presentation in public, it could be very, very expensive if you haven't seen that before you go into public. So that is, and things like that is happened many times. Many times it was the height that was planned wrong. Sometimes it was, I would say, a problem of communication between different offices, but that changed in the last, I would say, 5 years a lot because of BIM, Building Information Modeling. When we have shown our products about 20 years ago, people told us, you are already making building information modeling. And I said, well, it might look like, but I always say building information modeling is not visualization, and visualization is not building information modeling. But the failures happen, it's better, the failures happen in a virtual 3D model than if you are on the building site.
Yeah, no, so I mean, and obviously, I mean, imagine what just a bridge costs, right? And if you would have to deconstruct it, and also kind of the damage in the sense of like engineering companies having misplanned, I don't think they will get the next project very soon. It absolutely makes sense. And I mean, there was just one example, and I'm sure you could talk for hours about those examples.
We have been part of Stuttgart 21, and I have I have learned in the last 20 years that many projects have been failed, but nobody wants to talk about it later.
Mhm.
Because nobody wants to be the bad guy in the situation.
Yeah, no, absolutely. I mean, that's just being human, right? That absolutely makes sense. But I'm not sure. I mean, most people in the audience will are probably not aware of that specific project. But it's a massive it's a massive project, right? All right, but so one of the questions which I had is that, let's say we're in the context of public participation, where the inhabitants of a town can now, let's say, log into a website or get a presentation in where you visualize everything in 3D, for example. Can it actually be that there are also not only in the sense of positive effects that people will, how should I phrase this? Kind of seeing the situation so realistically because you know it's three-dimensionally correct in these communications. Are there some, or could there be cases where to actually not visualize the situation in 3D very honestly and transparently, that would potentially push projects further, and so that people, or let's say entities specifically, refrain from visualizing these things in 3D because it might generate too much uproar? Or is there more another tendency in the sense of, especially from, let's say, government projects, to actually really be honest and address all of these things and go through the process and be transparent about the dialogue? Because I've seen this in architectural visualization in past, because a lot of the stuff is highly political, and even if it's just a simple project. There was one example where I was actually tasked to create a visualization of a planned building, but the job was not given by the person that actually is planning the building or is selling the building, but the job was actually given by a person that would like to oppose this building to be built. And so it didn't have to be nice and fluffy and good looking and beautiful, but rather the opposite. It had to look kind of negative. And it had to look like it has a bad impact on the landscape. So there's always these different perspectives that you can play, and this is like politics and psychology are very often going very, very close together. Maybe you can elaborate a little bit on that.
Well, I've always made very good experiences if you are transparent and if you have an audience with a couple hundred people. There is always, I would say, 2 or 4 or 5 people that are trying to destroy you. When people are against a project that is critical in public, you cannot turn them around and make them being happy with the project. But you can do anything to be transparent, and most people, even if they're totally against the project, they are very happy because they understand what you're talking about. The German right, when you have projects in public, I would say 5 to 10 years ago, you had some plannings as a PDF, you put them onto a homepage, and then people could log in and look at the plans, and I would say not even 20% understand what the plans are showing. And if engineers go out, that is what happened until 10 years ago, only with plans in their hand or with a beamer and put plans to the wall, you can use your hands and your feet, but nobody will have the picture you have in your mind.
Mhm.
So even the people that are totally against projects, they are happy with the kind of presentation. That is what I learned.
Mhm. Mhm.
I mean, I'm sure that I'm talking like this because I have a company that is making visualizations, but I was at, I would say, way over 200 nights I spent with many people in sports halls, and many times the absolutely, how do you call that, people that are against, the absoluten Gegner,
Just opposing the project.
opposing, those people came up to us and were thankful for the presentation after 3 or 4 hours, because the first time they really understood what is happening. I mean, that is what I said. Everybody wants to be able to drive from A to B fast, if a train or if a car, but nobody wants to have a street with a 6-meter high noise protection wall right before his house. So you have to communicate what you're planning, and if there's no other options, you have to communicate that you make the best you can do.
Mm-hmm. Yeah, no, that makes absolute sense. And in English, this is called the NIMBYism. NIMBY in the sense of not in my backyard.
Not in my backyard, right?
Yeah. No, but I mean also as specifically, I think in the position where you are as a visualization company, right? You're also not taking sides. You cannot take sides, right? You're just there as you could almost say as a mediator, just talking about the truth, which helps definitely in your case.
That is the reason we only have one sun in our models. That is the real sun. So we cannot have 2 or 3 more lights just to make it nicer.
Yeah. No, but that's such that little detail is so important, right? Just you cannot place additional lights. It's the ground truth, it's geographic data, it's the true elevation, and the tool is designed with an engineering mindset and complete total honesty. And then that in itself is a really, really important statement, because all of these, because you specifically design everything to remove anything which could be misinterpreted or could be weaponized against the other position. Right? That's incredibly important to understand. And that, to me, this, for example, this little fact was completely, I wasn't aware of this. So this is a really nice little detail. Okay, let's see if there is another question here. No, I think everybody is blown away. All right, let me see if I do have, yes, I do have two more quick questions. So first of all, what are the different most common client types that you're working with, and how do you get in contact with those? That's kind of the first double question.
You mean what kind of clients we work for?
Yes, for the typical project.
Yeah, the typical projects, what is civil engineering is the government.
Mm-hmm.
Or it is a big planning company, like they are involved in the planning and they are looking for a visualization, and they call us because they say it's a big project, so we make a real-time model. Or they call us, we just have a small bridge, a pedestrian bridge that has to be put in one picture, and that is the small version. Another thing is, if you have a building site, it's the big building companies that call us. to make videos of future building sites, or to have a real-time model where you can switch the different steps. Because the building companies have software to show the building site, but it's so abstract and detailed that you have like 1,200 up to 1,800 steps, and it's our job to see what steps are important to see or important to communicate, and reduce that to maybe 5, 10, or at least 15 steps. So that's our clients.
Yeah, no, that makes sense. There's a question which came in from Martin, and he says, I'm not sure if I missed it, but what tools were used for this? So maybe he joined a bit late, but maybe you can do another quick pitch of the Vismo platform.
I think Martin is right. I did not even say it. I heard about Unreal from Marcus, but we use Unity. So our Vismo, our complete Vismo products are based on Unity.
Okay, but now I misunderstood the question, because you say it's based on Unity. I misunderstood that kind of which tools in the sense of Vismo, your product tools. Okay,
Vismo is our product, but it is based on Unity. Yeah, so we developed Vismo on Unity base.
Okay, that's cool to know. That's cool to know. And just in case for Martin, we are going to record, obviously, in case you missed the first part, we are going to record the presentation, or we are recording right now, and you can watch the video afterwards also on YouTube, right? All right, and then I have just a last question, at least from my end. So for people in the audience, for example, that are interested to come and work at Falcon Media, which type of job profiles do you have, and which type of education would you need?
I think I will know that when I'm 85 years old, because in our team, I mean, nowadays it is easier for us to say we are looking for a 3D artist. A 3D artist is the subscription of people that work in the 3D models. What we also have is what is Bauzeichner? I'm just looking it up. A draftsman, right?
Draftsman, yeah.
If you come as a draftsman, it is easy for us to help you getting a 3D artist for civil engineering. So we do a lot of schooling in-house in Falcon Media, and it takes, I would say, it takes maybe 2 to 4 months to come from a draftsman to a 3D artist for civil engineering.
Yeah. And so for the modeling of, let's say, the specific intersections, I would also assume that you guys are using some civil engineering tools like Civil 3D or whatnot.
The thing is, it depends on how far the planning is detailed. We can build 3D models based on a paper where somebody draws a line with the edding, or we can import IFC models from building information modeling. We also use Vestra in-house. It is a special planning software for infrastructure projects. We can also import 3ds Max and any other types of 3D models. So we cannot really say that we are working with 1 or 2 or 3 softwares. All the 3D models that are imported somehow end in Maya in-house. And then from Maya, we go into our Vismo.
Yeah. I knew the interface, the little triangle count and so on top. There must have been Maya.
Yeah.
Are very interesting. No, good to know. Very good to know, because right, again, this is so interesting for 3D artists, from just in general, let's say from with a education in game design or in film or in animation, that maybe have a complete flair for, okay, let's go into civil engineering. These types of presentations are eye-opening, or I hope that is one of the goals, to show these presentations so that people can also say, hey, there's I know what I'm doing, but maybe I would like to move into another discipline or into even another industry. This is why connecting all of these topics together, because they're common tools like Maya. I would never have guessed that this is Maya is one of the foundational tool for this type of planning and simulation for infrastructure, right? So this is really cool to see.
The reason for Maya is the historic. We started out with the SGI for 250,000. That was German marks in that time.
Yeah.
And that was running. What was the before Maya?
Power Animator.
No, I just forgot. I would have to look it up. It's too many years ago.
Because I think that the product where Maya grew out of was Power Animator, but I might be mistaken. But yeah, I mean, there are so many other tools. Alias Studio tools also exist.
It was from Alias Wavefront, yeah.
Alias Wavefront, yeah.
Yeah.
What was Power Animator? I'm curious. It doesn't matter. Different context. I'm gonna look that up afterwards. Yeah. No, and just because I didn't see another question coming in, but I do have one more, if I may, and this is regarding scaling. So you showed you have, I would assume, by far most projects that you have done are in Germany. Now, some of the projects are in Switzerland, and kind of, how easy is it for you, or are there any, let's say, constraint based on, let's say, definitions of geographic coordinate systems, or how easy is it basically to leave German territory to go to Switzerland, or could you potentially also do projects, I don't know, in the States or in Canada or in Australia, or are certain, or somehow are you linked to, I don't know, let's say German laws or German types of geographic data which are standardized?
No, we are not locked to Germany or to Europe. The project for us that was most far away was in Libya. So I would say we could work anywhere.
Yeah. That's very good to know. Let's hope many potential clients will see this presentation. All right, so last glance on the chat here. I don't see another question. Maybe you might get another one or two on Discord. But I would say let's wrap this day up. I just have a few more last slides to officially wrap up the day. But Oliver, it's been a great pleasure, and thank you so much for this extremely impressive presentation. Thank you so much.
Thank you.